Hi, everyone. Please take a seat if you have not already, and thank you so much. Okay, so hi, I'm Maanav, and with me I have
Justin.
And we're both he's an engineer, I'm a PM on the Onyx team at Microsoft. We're going to talk about what's new in torch.onnx. We've given this talk like 3 years in a row because things keep changing, and that's no different today. So let's jump into it. So, quick agenda. We're going to be talking about what Onyx and torch.onnx is. We'll do a quick what's new because there's so much to cover about what's new, and then we'll jump into examples and demos that are worked so that you can see how to use all these new features in your workflows. We'll have time for tips at the end and maybe Q&A if we're lucky. Let's hop in. Okay, so if you don't know already, Onyx is a wonderful precious gemstone, but it is also the Open Neural Network Exchange, and spelled a little differently. It's an open standard for AI models, and so it's open source, and we have committee meetings every month, or even more frequently, actually. And the idea is we take models that are PyTorch models and productionize them for the purpose of running them on device. Recent efforts, we've been really focused on Gen AI as the space has exploded over the last couple of years, especially the last 2. So it's really important to us to make sure that we are supporting these LLM workflows, as well as everything that comes alongside it to make sure that these models are running well, fast, and the way that you want them to in production environments. And torch.onnx is a module within PyTorch that enables conversion from PyTorch to Onyx to make sure that we can get these models production ready. So I'll hand it off to Justin now to talk a little bit about the features.
Thanks, Maanav. To start, the Onyx exporter has a new architecture. It's built on top of torch.export and ExportedProgram. We leverage torch.export and torch.fx to be the graph capturing mechanism. This replaces torch script to give us a clean, functionalized fx graph for conversion to Onyx. To ensure the translation is correct and efficient, we have also implemented a brand new conversion logic library using Onyx script that we call torch.lib, which has full support for dynamic shapes and for the latest Onyx opsets from 18 to 24. Starting from opset 23, we introduced attention, rotary embedding, and RMS normalization operators in Onyx. This will help you get a very clean graphs when you export large language models. The converted graph is represented as an OnyxIR model object. OnyxIR is a library released earlier this year for in-memory representation for Onyx. With this representation, you can create a path in OnyxIR and further run graph transformation on converted Onyx model if you so desired. How do I use the new exporter? To help you migrate, we kept the API largely the same. The option that tells the exporter to take the new path is called dynamo. We defaulted to true starting from PyTorch 2.9. One thing that has changed is how you supply dynamic shapes. You can supply the dynamic shapes arc the same way with torch export, or you can still supply dynamic axes in the transition period, and we'll do a best effort conversion for you in the API. But that's not guaranteed to be successful, so we suggest migrating to dynamic shapes when you can. With our migration to torch export, we gain the ability to work with code that is designed for PyTorch 2. One example is the ability to export control flows, whereas in the torch script era, you use a torch.jit script decorator to capture the control flow expression. PyTorch 2 introduced higher order operators like torch.const and torch.while to represent conditionals, torch.const for conditionals. Torch.onnx exporter has full support for that. Whenever there is a need for representing control flow logic that depends on the tensor data, you should use torch.const. For example, when you have a model that takes different forward passes based on the input data, you should use torch.const to ensure both logic paths are captured. Another feature we introduced to help you create clean Onyx graphs is what we call native Onyx operators. We implemented some Onyx operators using PyTorch 810 ops. These native operators work and feel like any other 810 operators. You can use them directly in your model forward function, and because the torch.onnx exporter understands these ops, they get mapped directly onto the corresponding single Onyx op at conversion. Here in an example, I'm using the ONNX attention operator in my forward function, and I'm able to get the attention op in the graph on the right. This can save you the hassle for running fusion down the road because they're already fused. We only implemented this for larger ONNX ops like attention and rotary embedding, and they're available to you in PyTorch 2.9. Now, you may be wondering, what happens if I want to use a custom op that is not implemented already? That would be a great question. We have made it easy for you. You can first use the is_in_ONNX_export API to detect whether it's inside ONNX export. Then use the torch.onnx.ops symbolic API to create any operator you want in the ONNX graph. This helps you maintain an ONNX-compatible model with logic that sits right next to your normal forward logic. And the section can also be interleaved with the normal A10 operators. So you can create very modular and ONNX-compatible code this way. Now let's talk about the return value of the torch.onnx export call, the ONNX program. First, the object shares tensors with existing PyTorch state dict. We store the return ONNX model inside ONNX IR format in this object, and in a very efficient way, so that it shares all the tensors with the PyTorch model, which makes it very memory efficient. It's also optimized. We run pattern-based fusion, constant propagation, and all other optimization to give you a very clean and pre-optimized graph. It can be run directly on Torch tensors, so you can verify the model with your existing Torch eager module, and beneath it, it runs ONNX runtime on Torch tensors, so you can do validation very easily. If you want to do further graph manipulation, you can do so with ONNX IR by accessing the model with onnxprogram.model. And when you're done, you can simply call onnxprogram.save, which will do efficient serialization. It also takes care of the best practices like aligning tensor data so that they can be memory mapped when inferencing. Now, I'll hand it off to Maanav to talk us through the validation tools and give us a demo.
All right, thanks so much. So we worked very hard to get this model working and exported, and that's wonderful. And then the model didn't really give us the output that we were expecting. That's weird. That's what validation tools are for. So torch.onnx verification can run on a model, and then we can diagnose whether the model was accurately exported or not. So that is a great way to start, but we've also built a plugin that we use for Model Explorer that we have used to pinpoint numeric discrepancies. So if anything happens, we can see that. So in this case, we can see that we have a different color than green, which obviously doesn't mean great, and there's a discrepancy numerically. So we know that this is kind of where in the graph we started to have problems, and so we can look into that specific operator to figure out where the problem is, and then move forward to fix that op, either by implementing it as a custom op or just addressing what's going on in the graph. Cool. So after that, we were able to successfully export a model. And we went ahead and did that, thanks to Justin, and we exported a couple models. I'll be demoing Gemma 3, but we were also able to get Qwen 3 running up and easy, and we'll do Gemma 3 just because it's really small and easy to run. So I hope you can see this okay. Yeah, so at Microsoft, we've been working on a consumer-first solution to an on-device inference, and we've worked with lots of partners to get the best on-device inference experience. So we've worked with AMD, Intel, Qualcomm, and NVIDIA to make sure that we're shipping models that are locally really, really powerful so that when you're shipping to consumers on device, you have options. Anyway, that's besides the point. We're going to export or demo this exported model using it. So I have a pre-release version of Foundry, but all of them work. I will run Foundry model list, and hopefully it'll spit up this large list of models we have. We have GPT, OSS, etc. But what we don't have right now quite yet is Gemma or Qwen. So we can look at this large cache that I have models set up for, and we'll go ahead and run. Wow, this browser's this terminal's great. It's doing everything for me. But yeah, I'll go ahead and run Gemma 3 that Justin exported for me in a verbose way, and we'll load the model into memory. One thing that I want to mention is this is not fully optimized. We got it exported and did baseline work. So we'll go ahead and ask some questions. We'll have it write me a poem about PyTorch and ONNX. I hope my spelling's okay. Spelled poem wrong, but it seems to have understood. Great work, Gemma. And it's called the neural streams. Okay, we're gonna debate whether we like that or not, but it's gonna go ahead and do its thing, and it's working very well on device. So we're using a float 32 model. It's not quantized at all, and this is also an 11th gen Intel CPU, so it's quite old, but we can see that we're doing a great job in getting wonderful tokens per second. And as we scale up to GPU and NPU inference also, we can get great results. But it's an example of taking an ONNX model that we were able to take from a base PyTorch model, we exported it, and as an output, we got a running model that we can productionize and ship in apps if we want. I'm glad that it's doing a great job there. We'll maybe do one more query. I'll go ahead and Control-C out, and we'll have it recursive BFS in Python, and we'll see how that goes. And yeah, it's just off to the races. We have Gemma, Quen, and Ed, and the beauty of learning these ways of exporting that Justin talked about earlier is that we can take whatever model we want and hopefully get it exported so that we're good to run. In any case, we have some tips here for successful export, but we'll leave them in the repo that we have access to, so feel free to look into those. And yeah, we just wanted to thank you so much for the time. There's QR codes there, and so we'll leave them up for a while. Yeah, that's all.
Thank you.